Dear students, in continuation of our the previous results discussion about the conformal transformation, w is equal to z square and e to the power z. Let me consider the last case here. W is equal to z plus 1 upon z, where the denominator z is other than 0. Putting z is equal to r into e to the power I theta, we are taking z is equal to u plus iv in the left side. In the right side, putting the value of r into e to the power I theta plus 1 upon z becomes what? 1 upon r into e to the power minus I theta. By equating the terms in the right side, equating real and imaginary parts, what happens here? U is equal to r plus 1 upon r cos theta and v equal to r minus 1 upon r sin theta. Call this much as equation 1. Now we shall eliminate r and theta from this equation 1. Refer here. Now to eliminate theta, let us put 1 in the form. You just observe here, u upon r plus r, taking r plus 1 upon r to the denominator in the left side is equal to cos theta. Similarly, v upon 1 minus r equal to sin theta. Squaring and adding these two terms, what happens here? U square upon r plus 1 upon r bracket square plus v square upon r minus 1 upon r is 1 upon r bracket square equal to 1. That is cos square theta plus sin square theta equal to 1 in the right side, where r is not equal to 1. To eliminate r, let us put 1, this one equation in the form u upon cos theta equal to r plus 1 upon r, v upon sin theta equal to r minus 1 upon r. Now squaring and subtracting, refer here. In the previous one we are adding, now we are subtracting. Therefore u square upon cos square theta minus v square upon sin square theta is equal to r plus 1 upon r bracket square minus of r minus 1 upon r bracket square. The addition, subtraction, what is the things in the right side will reduce us to 4. Therefore u square upon, taking 4 to denominators in the left side, u square upon 2 cos theta bracket square minus v square upon 2 sin theta bracket square is equal to 1. Since z is equal to r into e to the power I theta, as we have seen, we have taken in the earlier of this example. Therefore modulus of z equal to r and amplitude of z is equal to 0. We know that this case while doing the polar form of any complex number. Therefore modulus of z is equal to r and x square plus y square equal to r square. It is a known fact, because x equal to r cos theta, y is equal to r sin theta becomes x square plus r square equal to x square plus y square equal to r square. This represents a circle with a center at origin and radius r in the z plane, where r is a constant. Therefore amplitude of z theta is equal to tan inverse of y upon x. Therefore y upon x equal to tan theta, where theta is a constant. This represents a straight line in the z plane. Refer here, straight line in the z plane. You can observe this figure. Next, come to the case 1. Let r equal to constant, then the equation 2 becomes u square upon v square plus v square upon b square equal to 1, where a equal to r plus 1 upon r, b is equal to 1 minus r minus 1 upon r. Equation 2 is shown here. This represents an ellipse in the w plane. Observe this straight line, this equation, u square upon a square plus v square upon b square equal to 1. This represents an ellipse in the w plane with foci plus or minus root of a square minus b square comma 0, that is plus or minus 2 0. That is putting a square minus b square under square root. Using these a and b, after simplification this will become plus or minus 2 0. Hence we concluded that the circle modulus of z is equal to r. We have taken modulus of z equal to r in the z plane maps onto an ellipse in the w plane with foci plus or minus 2 0. You will observe here, this is the figure of the ellipse. Next, case 2. Let theta equal to constant, because in the case 1 we have taken r is equal to constant. Now we shall consider theta equals to constant. Then the equation 3. Where is the equation 3? This is the equation 3 becomes u square upon a square minus b square upon b square equal to 1, where a equal to 2 cos theta, b is equal to 2 sin theta. Again from the equation 3, this represents a hyperbola in the w plane with foci plus or minus root of a square plus b square comma 0, that is plus or minus 2 0. Observe these two curves in the second figure. Hence we concluded that the straight line passing through the origin in the z plane maps onto a hyperbola in the w plane with foci plus or minus 2 0. Here, my dear students, refer the case 1. Case 1 refers to elliptic curve, and the case 2 refers to an hyperbolic curve. This is the difference between where r equal to cos theta and theta equal to constant. We are taking r as a constant at one condition, theta as a constant in the second condition, to get ellipse and hyperbolic curve, which is shown in the second figure. My dear students, let me repeat the things once again. As far as the importance of the both IA and examination is concerned, these three results, W is equal to Z square, E to the power Z, and Z plus 1 upon Z, they are very important, which carries 7 marks in the question paper. Out of these three, you can expect definitely any one, because these three results are as like as derivation or a theorem, or you can call it a property also. Therefore, go for the practice, do the things clearly, neatly, observe all the things, draw the figure correctly in the examination also with your pen. Do not use the pencil, so that you can get maximum marks from these three properties. Okay, thank you.